So Ibrahim and Juan Lucas is going to join us as well. Juan Lucas, and they're going to talk on applying and studying the effect of human urine nutrient solutions on plant growth.
Hello everyone, good afternoon. Thanks Jeff for introducing us. Everybody knows me from my health management role. No one knows me from working in horticulture or agriculture. But I've been doing that for 20 years, so I've got other experience. So here Juan is joining me from the Botanic Garden. So he took the role of PI there after I left. And then we're still working with the Botanic Garden on testing herbal on different species. So the collaboration between the Botanic Garden and ETS dates back to probably 2018 and 2019 on testing herbal since the beginning. And then we've tested a few crops, and then this year we're testing spearmint. Our research project falls under the fourth theme of the NICE Hub, which is fertilizers end use, because the Botanic Garden basically are end users, and they purchase fertilizer to apply it in the nursery or on turf. So we're trying to actually fulfill that theme in there. And the hub KPIs that we are trying to achieve in that or contribute to are basically publications, industry visits, number of government, community briefing, and then journal articles and media releases. So we so far are on track for 2023, and then we are actually working harder to get things done quicker. But there's so many changes in the Botanic Gardens, it's a bit challenging to keep everything on track. So this study was basically very simple, very straightforward, not too complicated because we had some budget restrictions and space restrictions. So our target was to basically study the effect of the fertilizer compared to a commercial one on the growth of spearmint. And then we tested two fertilizers, urban and commercial one, and then 3 different potting media. And of course we wanted to investigate if there's any other inhibitions happening while we are applying the herbal fertilizer. The study site is the Botanic Garden Nursery, top yard section, which is this section here. So it's between the calyx and then the Sydney Fernery. It's a north-facing site where we got sun in winter around 4 to 6 hours, depending on the sunny days, because the sun goes behind the towers of the city. So it's a very short photo period every day. The experimental layout was a 2x3 factorial that we've selected with 2 different fertilizer treatments and 3 potting medias. And then we've done 5 replications per combination of treatments. We've applied both fertilizers, so we have here the jerry cans that we prepared the fertilizer with. That's herbal, and then that's the calcium magnesium grower. So we applied 200 ppm on a weekly basis at 200 milliliters per plant. And then that's the experimental layout. So the location was on a bench. It's around 800 mil wide and probably 6 meters long. So I'll pass to Juan to talk about the results that we got.
This study was conducted over a span of 6 weeks, and after we collect the data, we obtain the following result. In this first graph, we can see the average height of plant based on the applied treatment. The 3 groups on the left represent plants treated with urine fertilizer, while the three groups on the right correspond to plants treated with commercial fertilizer. Between these groups, each bar represents the weekly average height for each treatment. A trend of greater growth is noted in all treatments where commercial fertilizer was used. Among these, the treatment called CMB, which consisted of a vermiculite substrate, stood out. Another observed aspect is that the variability between treatments using commercial fertilizer is higher than those treatments with urine fertilizer. It is highlighted that treatment under urine fertilization yielded more homogeneous results. In this second graph, the total number of stocks per treatment is displayed. This process was also carried out and analyzed over 6 weeks. We can see the same categories and distinction between urine fertilizer, the first 3 groups, and the commercial fertilizer, the next 3 groups. It's a greater indication in the number of stock per plant when commercial fertilizer is applied. Again, the most significant growth and stock production trends are observed in the CMB treatment. In this case, the least development stock per treatment is in the UPP, that in the middle. In this last graph, the average weight of biomass per treatment was analyzed, and the blue bars are the weight of the wet biomass, and the orange bar are the weight of dry biomass. Again, it's observed that the highest weights were recorded in all treatments where commercial fertilizer was applied, with CMB being the most notable in this category. And in relationship to the data obtained, we can affirm that treatment with urine fertilizer yielded lower values than treatment where commercial fertilizer was applied. Secondly, the CMB treatment was proven to be the best combination of fertilizer and substrate for the development and growth of mint plants. And on the other hand, the UPP treatment showed unfavorable results when analyzing the growth of mint. Lastly, some plants exhibited poor growth due to the presence of some pathogens, such as mint rust and Puccinia mentale. Nonetheless, further data analysis could be conducted to verify the significant difference between treatments. And to conclude this presentation, we would like to thank the Australian Research Council for their help throughout this project. We would also like to thank Johnson and Jay Xian from UTAs and FEIT for providing the urine fertilizer. And last but not least, to the Royal Botanic Garden of Sydney for their support, especially to Randy Singh's team. Thank you very much.